Okay, so this second half of your notes is going to be at least a little bit shorter than the first one. This is just identifying a few more properties. These are properties we already use, but it's just giving names to them and then telling you why these properties allow us to do the things that we do with solving problems, and more specifically solving equations. So the reflexive property basically says that things are equal to themselves. So for numbers, 5 is equal to 5. Segment lengths, AB is equal to itself. Angles, angle A is equal to angle A. So this is true across numbers, segments, and angles. The symmetric property says if two things are equal, I can write that equation two different ways. I can write it as A equals B or B equals A. So equations have symmetry. They have the same truth value written forwards or backwards. The transitive property is a little bit trickier to follow, but it does make logical sense. If A equals B and B equals C, then it makes sense that A would have to equal C. So basically, an example of that with numbers and variables maybe, if I said x equals 5 and 5 equals y, it's not a big leap to say that x is equal to y because they're both 5. So it's just kind of taking two statements and writing them as one, okay? So in example 4, you're going to get just a short introduction to what a proof is. So we're going to use geometry concepts to show whether Dba is equal or congruent to EBC. So the first thing we notice here is, I know in your notes it's not marked very well. This is D, point D. This is point E on the right. The first thing I can assume, the first thing I look at in this diagram, I know that the measure of angle 1 is equal to the measure of angle 3. And the reason I know that is because they are marked as congruent. They have those congruence markings. So the reasoning behind that is that they are marked that way. Now the next thing I can look at is we are talking about Dba and Ebc. So looking at Dba, I'm going to trace that angle for a moment. Dba is the result of adding together angles 2 and 3. So I'm going to say the measure of Dba equals the measure of angle 2 plus the measure of angle 3. And that goes kind of back to Unit 1. That's that angle addition rule. That's the justification. So we know that that angle is the result of adding together angles 2 and 3. So next, part of it is realizing angle 3 and angle 1 are the same measure, so I can write this above equation a little bit differently. The measure of angle Dba. All I'm going to do is I'm going to substitute out 3, and I'm going to substitute in 1. So I can write this as the measure of angle 1 plus the measure of angle 2 is equal to Dba. So what I did there, I'm going to highlight this. I substituted 1 for 3 because I know they're the same measure. So that's me using substitution to rewrite that. Okay? So this is setting us up for something a little bit later. So I'm going to move to a different color just to show EBC. Okay? EBC, I'm going to use the same logic. The measure of EBC is equal to angle 2 plus angle 1. So I'm just going to do angle 1 plus measure of angle 2. And that's still our angle addition rule. Okay? So if we look at this logically, look at 1 plus 2 is equal to EBC. 1 plus 2 is equal to DBA. So it's not a big stretch to say DBA is equal to EBC, and that's by our transitive property, right? I know that's a little confusing at first, but if you think about it, if they're both equal to the same thing, they're equal to each other. So if they're both equal to this sum, that means that they are equal to each other. Okay? So, moving ahead, I just want you guys to see if you can translate from the properties on the previous page to the properties that are shown by these 3 examples. So try these. Actually, for these, I'm going to go through these with you. Never mind. I want to go through these with you, because then I'll have you do the last few on your own. So in this example, it says if 6 equals 7, angle 6 equals angle 7, then angle 7 equals angle 6. So that shows the symmetry of equations. So that is the symmetric property. So you could just write symmetric. Okay, that's a symmetric property. Next, 34 degrees is equal to 34 degrees. A value is equal to itself is a reflection of the reflexive property. That's the reflexive property. And then finally, if angle 1 equals angle 2 and angle 2 equals angle 5, that means angle 1 equals angle 5. So that is an example of the transitive property. So mainly what I am going to ask you to do is identify the properties from the tables. That is the main thing. That angle example we just did, I just wanted to show how we'd go through proving that 2 angles are equal to each other. So what I'm going to do is I'm going to skip example 5. Okay, I'm going to skip example 5. And I'm just going to move to the guided practice. I'm going to ask that you try these guided practice problems on your own and then check your answers with me once you are ready. So I'll give you a few seconds to pause and work through those, and then I'll show my answers. Okay, so the reflection of these 3 properties. It says if JK equals KL and KL equals 16, that means JK is 16. So that is an example of the transitive property. It takes 2 things that seem different and saying they're both equal to KL, so they're equal to each other. So that's the transitive property. For 11, writing an equation forwards and backwards shows the symmetry of equations. That is the symmetric property. And then finally, zy is equal to itself. That is the reflexive property. So I'm going to have you move on to an activity that helps you kind of identify the properties and name the properties. What I'm going to say is use your notes. These notes should be helpful. Use those tables to help you reference these properties. When you get to the checkpoint, you're going to be able to use your notes on the checkpoint. So I'm going to encourage you to use your notes on the checkpoint to identify those properties, because I really want to know that you can name them, but not that you have to memorize them. Okay? So you can move on to the next step in the lesson.